Hello guys, welcome to the new course of the control systems, right? My name is Sai Kiran Singarao. And I'll be taking the control systems course for you, right? My qualification is I have done my Bachelor's of Engineering from University College of Engineering, Osmania University, Hyderabad. And I've done my Master's, that is M.Tech from Indian Institute of Science, Bangalore. And I secured a GATE rank of 437. Right, so this is about me. I've been teaching from last 8+ years. Right, so this is a brief introduction about me. Now let me talk about the course. In this course, control systems, this course is common for 3 departments, that is EE, ECE and IN, right? So this is one of the easiest and scoring subjects. The first point you have to remember is it is easy, mathematical and scoring. So they are very limited concepts, and when mathematics is involved, then nice questions can be formed, but it is very easy, sir, right? It's a scoring subject. It has a weightage in GATE for all the branches till 8 marks, right? For E, you can get till 8 marks or 9 marks also sometimes. For EC, you get maximum of 8 marks or 6 marks. IN also 8 marks to 10 marks. So let me take the average number as 8 marks. Sometimes you might even get 10 marks, right? So these are free numbers, sir. I would say very easy numbers, I would say, right? So let me tell you what all topics are there in this particular subject, and the topics are designed in a specific manner, sir, right? So the next one, if I go to the next slide, I have given you the topics like this. The first topic is basically introduction. So whenever we start a subject, we will talk about the introduction of it. We will see what are there in that, right? Now what we'll be doing in this particular subject is you will have a physical world equipment, sir. Say you have a system built, right? Now you have to analyze that system, so you will be doing certain mathematical modeling to it. So that is what we'll be doing, sir. We'll understand what is the basics of control systems. When I say basics of control systems, that what is the definition of a control system, what is the definition of open loop control systems, closed loop control systems, effect of feedback, all these things will come, right? Once you understood the basics, then you will go to the mathematical model. That means whatever the system is there, you will try to write an equation for it. Once you have written equation for it, you can start analyzing it, right? Now there can be combination of blocks in particular, or in a particular systems there can be combination of subsystems. To entirely write a model for them, we have certain techniques called block diagram reduction technique and signal flow graph, right? So from this question, from this particular topic, you can definitely expect a question either from SFG or from block diagram, or a basic question like what is the gain, what is the advantage of open loop, what is the advantage of closed loop, effect of feedback. On these kind of topics you can get a question. So this is a very important topic. These two things are very necessary, sir, right? For ESE, this is also important. For mathematical modeling, force voltage analogy, force current analogy, torque voltage analogy, torque current analogy, right? Because we'll be dealing with the mechanical systems, so we'll try to convert them into a mathematical model in this particular chapter, right? So you had a system, now you had modeled it, so you have the mathematical model present to you. Next, what do you do, sir? Next we'll go to the next chapter, where we'll be studying the time domain analysis. So that is time response analysis of an LTI system. So what's an LTI system, sir? Now you will understand this while I teach you in the first chapter, that is linear time invariant system. In linear time invariant system, what do we do, sir? So you have the system ready with you now. We will try to give certain standard inputs because we want to check how the system responds. That means what is the time it takes to give the output, or till what time it reaches the maximum value of it, or till what time it settles. So what is the maximum peak overshoot? So those kind of things can be tested by giving standard input. So first we'll study about certain standard input, that is step input, ramp input, parabolic input, impulse input. So we'll study information about that. Once we study this, then we will give these standard inputs to the system and we will find the response, right? Once you have found the response, then you will see that, okay, this is a response for this kind of input. So this behaves good for this kind of input, this does not behave good for this kind of input. So we will be doing the analysis like this, right? Next, assume you have two systems. If you want to compare the two systems, when you want to compare the two systems, then you will be needing certain specification or certain chart of sheet with which you can compare. Say there are two motors, right? One motor turns on with a time delay of say 0.1 second. The other motor turns on with a time delay of say 0.01 millisecond. So the delay time or the processing time, or you have stopped it, the settling, right? So those kind of time domain specifications you will be studying, you will be doing the derivations also. And once you have derived this particular responses, you will see that what is the error in the input and output, right? So that kind of error analysis can also be done. So of all the chapters, second chapter, this is the second chapter, sir. This is easiest chapter. This is basically easy and scoring chapters, right? Definitely 2 marks will come from this, right? It can be from error or it can be from specifications. The responses, you better learn the responses. It is used in first chapter or it is also used in coming chapter, but the question getting probability is from these last two topics, right? So till now what we have done, we had system, we have given inputs and we have seen outputs. You can compare two systems by giving time domain specifications, right? Now next, if you want to see, that is the concept of stability. Concept of stability is what, sir? BIBO. What is BIBO? Bounded input. If you give bounded input, you should get bounded output. If you give bounded input, you should get what, sir? Bounded output, right? And analysis. So how do you do that? We'll have to see. So you have the system, you have given inputs, you have taken outputs, you are happy with it. Now you want to see that for certain inputs, the response you are getting is not bounded. That means you turned on the motor, it started rotating and the speed has become so high that it got mechanically damaged. That means that particular input voltage which you have given to that particular motor is not stable, right? Even if your input is bounded, the output is unbounded. That means the system has braked, right? So we will see the concept of stability, that is what is bounded input, bounded output stability. Then we will see techniques, sir. What are these? These are your techniques to determine stability. The first one is RH criteria. The second one is root locus. Actually in stability till RH criteria is only there. The root locus diagram is again an entirely new chapter, but we can find the stability using root locus diagram also. In root locus diagram, what will be there, sir? We will try to plot the roots. Sir, what are roots now? When you model the mathematical, when you model the system into a mathematical model, you will have something called poles and zeros. So we'll try to see how those movement of poles and zeros will happen, and based on the movement, how the stability will get affected. So that is being studied in this chapter. So entirely you had a system, you have given inputs, you have seen the outputs, now you are checking the stability, right? So this is done using time domain analysis and stability analysis. Next chapter is the frequency domain analysis, right? Now let me tell you, the first 3 units or the first 3 chapters are easy part of the control systems. The 4th, 5th and 6th units are little bit of conceptual, right? I will not say they are tough, but conceptual, and most of the students feel these topics as difficult, right? So you better put more focus on this 4th, 5th and 6th chapter, especially the 4th chapter, sir, right? This particular chapter, because this is a very important topic. The polar and Nyquist plot, Bode is also very important, and this frequency domain specifications is somehow there, right? So what do we do in frequency response analysis? We have seen, sir, we have seen time domain analysis. Now why do we have to see frequency domain analysis, right? Now this subject is common for what, sir? This subject is common for your electrical fellows, electronics fellows and instrumentation fellows, right? The time domain which we have seen is can be put for mechanical systems. Say you have a mechanical system which has motor, which has shaft, which has pick and place machine, something like that. then what you do, you will see the time, you will measure the parameters in terms of time, that how much time it is taking to process or how much time it is taking to settle, right? Or by how much time it will go to the maximum output, right? But if you talk in terms of electronic fellows specifically and electrical also, if you talk in terms of electronic fellows, we will deal in frequencies, right? Say I'm talking about an audio device, or I'm talking about sending communication. So whenever I'm talking about these things, I will have to deal with frequency. That means I will have to do the analysis also in frequency, sir. That's why this particular topic, that is frequency analysis. In this particular topic, we'll do nothing, sir. We'll simply vary the frequency and we will see how the system responds, right? So we will see at what desired frequency or at what frequency the systems give the desired output, right? So that is what is called frequency response analysis. This is very important chapter for EE and EC. All these topics are important, sir. Like frequency response means we will see for changing frequency how the output will be changed. Frequency domain specifications means to compare any two system frequencies. To compare response of any two systems, we will use this domain specifications, frequency domain specifications. Now, Bode plot is also called as a frequency plot, sir. With respect to frequency, how the magnitude of response and how the phase of response is changing. Similarly, polar plot and Nyquist plot, these are proper mathematical methods to determine the stability. You can determine the stability and do the response only in this entire chapter. Whatever we done in the second chapter and third chapter, whatever we done in the second chapter and third chapter for time domain analysis, the same thing can be done in this fourth chapter for frequency domain analysis. We will see the response, we will also find the stability, right? So using this Bode plot and polar plots, they are so powerful that they will give the response as well as they will tell you about the information of the stability, right? Next, once you have seen time domain analysis, once you have seen the frequency domain analysis, you have seen the stability of it. Now you will be coming to the designing parts, right? So how do you design the control systems? That means if you have a desired output to come, then how do you design a control system? Or you can also understand it that you have a system, the system's output is coming, but you want to improve the system output, sir. If you want to improve the system output, what kind of equipment you can put? Some controller or compensator you can put, so that the performance can become much better. So that is what we'll be doing. We'll be designing and analyzing something called controllers and compensators. So what are controllers and compensators, sir? They are just used to improve the performance or reduce the error, things like that. So the controllers which I'll be doing is P controller, that is proportional, integral, differential, proportional integral, proportional differential, proportional integral differential. Now, similarly, there is lot of similarity between these two fellows: lag controller, lag compensator, lead compensator, lag lead compensator, and lead lag compensator, right? You can get theoretical questions from this. What happens to the output if you put a lag compensator? What happens to the error if you put lead compensator? These kind of questions can be expected from this particular chapter. So this is also a very good chapter, sir. If I want to write the weightage from this, these two topics are very important, sir, right? From this, obviously the last two topics are very important. Here also last two topics are important. Here also last two topics are important. So whatever is at the end of the chapter, make sure you understand that properly. Here everything is important, but there is a similarity between these two fellows. And if I see that PPID, these are important here. These are lag lead. In this, there is nothing like important and unimportant, sir. Everything is important from this chapter. Next, the last chapter is state variable analysis. In state variable analysis, what we'll see, sir? This is called state space model, also I can call it as state model or state space model. Now, whatever we have done so far in the first 5 units is one side, and what we are doing in the 6th unit, the last unit, is one side, sir. These are what we did in the first unit. We basically modeled it. In the second unit, we have seen the time domain response and error analysis. In the third unit, we have seen the stability of it. In the fourth unit, we have seen the frequency response and stability. In the fifth unit, we have designed it, or we have added some controllers and compensators which can do what, sir? Which can improve the desired performance. So you kind of completed a system, sir. But when you come to the state variable analysis, whatever analysis we have done was first seesaw system, sir. For what kind of system? Single input, single output system. So whatever discussion we have done so far, we have assumed that the single input is there and single output is there. But in the practical world, there won't be a single input or single output, sir. There will be multiple inputs and multiple outputs. So we have to deal with something called MIMO systems. What is MIMO systems? MIMO systems are basically multiple input, multiple output. So whenever you have multiple input, multiple output system, then we will use something called state variable analysis. In single variable input, so you will have a single variable, you will have a single input variable, you will have a single output variable, so you can form an equation deriving it. Now since here you will have more number of inputs, more number of outputs, there will be a matrix or set of equations forming. Those set of equations can be defined or they can be analyzed using matrix algebra. So this particular topic has matrices involved. So first, for any given system model, we will write the state space model to it, right? Then we will write the state equations governing it. Then we'll try to find the solution of the state equation using something called state transition matrix. Then we will see something called controllability and observability. In this, the most important is this, sir. For 2 marks, for 1 mark, this, sir. Right? And for 1 mark, this also. Right? So these are the topics involved in this particular control systems. I will ask you to put more focus on this particular last chapter, 4th chapter and 2nd, 3rd chapter, sir. Right? Especially this is important. Definitely you will get a 2 marks. Definitely 2 marks. Sometimes 3 marks is also asked from this chapter. Right? Whereas if you go to this particular chapter, 1 mark or at maximum 2 mark. They can club it with Blodia plot and they can ask it for 2 marks. Right? If I ask you here, definitely 2 marks. Definitely 2 marks. Not more than 2 marks. Here also definitely 2 marks or sometimes RH criteria 1 mark. Here definitely 2 marks. This one, the first chapter, they might actually ask you a 1 mark question or a 2 marks question, or they might skip a question from this basics and they might go to frequency response and ask you, sir. Right? So this was the course overview of your control systems. I'll stop this here. In the next class when we come, we'll start with the first chapter. Let's meet there, sir. Thank you. So that was the lecture, sir. I hope you enjoyed the lecture and gained some knowledge. For more content like this, please subscribe to our channel OCTEMY and also like and share it with your friends. And if you have any valuable feedback or doubts, you can always write down in the comments. And to watch my entire playlist and the full course, please enroll with us. Thank you, sir.